it's not surprising. Over 1 million avalanches rumble down the world's mountains every year. Their power is mind-boggling. A slide can travel in excess of 200 miles per hour. Carrying up to 1 million tons of ice and snow, reinforced concrete is torn to shreds. The utter destruction is catastrophic. Over the last decade, thousands have been killed. Today, there is a growing number of backcountry operators trying to predict when and where snow might turn violent. Mike Wigley is among them. He runs one of the largest teleskiing operations in the Canadian Rockies. Here in Blue River, British Columbia, many of the world's elite skiers and snowboarders push the envelope of the extreme in some of the best powder found on Earth. This is their terrain, and most are well aware and trained for the risks. It's the weekend novices that worry people like Mike Wigley. He believes one major factor often overlooked in the backcountry is common sense.
We have grown up in the mountains and we go out every day, and we know it reasonably well. But what's happening is the urban cowboys invading the mountains. Some don't have the clue the danger they're entering.
And the danger is real. The heavy, moisture-laden weather systems that deliver such great powder to Western Canada also set the stage for frequent and violent bursts of nature. For a human swallowed up in the raging fury, the experience is unimaginable. If trauma doesn't kill them, suffocation likely will. As a slide begins to slow down, it solidifies. The victim becomes locked in the cement-like grip of the debris. Struggling to breathe, they melt the snow around their face, where it refreezes, forming an ice mask, shutting out the flow of oxygen. Only 30% of those completely buried survive, usually by rescue from others in their immediate group.
I couldn't move.
Mike Wigley is dedicated to helping make this part of the Canadian Rockies safer for the thousands who venture here each year.
We play in snow, play in the mountains, and that's where avalanches happen.
What a playground, eh?
But as complex they appear to be and mystic, there's also simplicity in there.
The recipe for an avalanche is simple if you know what to look for. And Wigley and his team start each day by spying the snowy peaks for signs of trouble.
First, you have to identify the potential slope. And then you have to identify the stability of that slope. And if the stability is poor, moderate, and leading into a gully, that's a sure killer. I don't go there.
Modern snow science is part of the operation, and the guides meet twice a day to exchange information in what is, in effect, an avalanche war room.
1,500 drop is east and west and wedge and tree.
At its simplest level, an avalanche is the end result of a constant tug of war between snow and gravity. Factors such as temperature, radiation, and humidity are key players in that exchange.
You have to feel the various layers.
Heavy squall activity.
Winds light to moderate. Temperatures -2 and +4.
To better understand how these things influence snow stability, Wigley has formed a critical alliance with Dr. Bruce Jameson, an avalanche expert from the University of Calgary.
The low is a low-density layer in there.
Is there any faceting in that shear under the stiff layer?
I don't.
The operation provides a wonderful interaction. We share information on the morning.
When you do a profile,
If someone sees an avalanche one day, we're able to go there the next day and get some information on that. Plus, we've been able to collect a really wonderful data set of the snowpack conditions and weather measurements that are associated with avalanches, both natural avalanches and human-triggered avalanches.
Jameson examined snow samples collected from the field to dissect their underlying structure. Most avalanches are caused when a fresh new layer of snow sits on top of an old one. Fluctuations in temperature and humidity cause the old snow to loosen. The weight of the new layer is too much to support. This can be seen in the tiny ice crystals which give snow its stability. Small rounded crystals bond together tightly, creating a strong pack. While other crystals have become large and angular, forming a weak layer underneath. It's like having a layer of grease under the harder pack. A time bomb waiting for gravity or an unaware skier to set the upper layer in motion. But predicting when and where a slide might actually start is still elusive, particularly over vast areas of terrain where backcountry enthusiasts are likely to venture.
Nuts emerging is one of the central problems. Is you can do an observation of the snowpack here, and how does that relate to the snowpack further away? It might tell you it's stable here, but is it necessarily stable further away from that? And that's the spatial variability problem that is a real challenge.
While scientists grapple with many uncertainties, guides remain responsible for the safety of those who come here. And no skier will hit the mountain without a heavy dose of avalanche awareness training.
Come on in nice and close, because this is really, really important. This is what is called...
The basic tools of survival are demonstrated. A shovel,
Would you assemble that for me?
a collapsible probe,
Just throw that out. When you're probing snow, you won't really feel much resistance. When you strike somebody, it's quite soft.
and most importantly, an avalanche beacon, which sends out signals to help locate someone caught in a slide.
The one thing about this particular beacon is that it transmits a signal and it also receives a signal. So,
without a beacon, 2 out of 3 avalanche victims will die.
Slide's gone that way. I move slowly like this.
In the world of avalanche safety, other important issues are starting to emerge.
We're just now starting in the avalanche profession to look at how human factors affect our decisions and how we can deal with that. Judgment is vulnerable. Blue sky, being out there with friends, being tired, being at the end of the day. All these factors can affect our judgment. And we really need to stick to the facts to look at what's going on in the snowpack, what's going on in the weather, how steep the slope is, make the decisions on those facts so that we can be out there enjoying the mountains in winter for many years.
In many parts of the world, venturing into avalanche country is not always a choice. It can be a fact of life. Norway is one of the most dramatic places in all of Europe. But within this enchanted land of majestic mountains and breathtaking fjords, frequent and deadly avalanches are part of everyday life. Krister Christensen is sort of an avalanche hunter. His job is to keep people out of harm's way. A task made difficult by the unique shape of Norway's western slopes.
What's special about topography in this area is that we have the glacier-carved valleys. The slopes on top are about 30 degrees or so, and that's where the avalanche will start. But when the avalanche comes over the cliff, it smashes down into the valley. We'll have a tremendous air blast in the valley.
Hurricane-force winds mixed with tons of uncontrolled ice and snow wreak havoc across Norway every winter. Villages have been flattened, countless lives lost. Highways choked off and paralyzed. Yet the danger is hard to escape.
The problem with the habitation in this area has to do with the limited space that are safe enough to build houses in. And also the communication lines between those areas are endangered by avalanches. You have to build a road between the steep mountain and the fjord in many cases.
In parts of Norway, tragedies often strike in ways unimaginable to the rest of the world. As seen recently in the community of Lyngen, where a group of seniors were traveling by bus on what they thought was an ordinary day. But up ahead, an avalanche had blocked the highway, and their plans would be put on hold forever. As more vehicles arrived, motorists wondered how long it would be before authorities could clear the road. Suddenly, the unthinkable happened. Directly above, a raging avalanche was bearing down on the group. In an instant, the bus and a front loader were hurled like toys into the icy fjord. In all, 7 people were swept away. 5 would die, including everyone aboard the bus. As the first policeman on the scene, Arne Marcus Svensson speaks for many in this community.
Lyngen is a place where everyone knows everyone else, so it's really difficult because everyone becomes involved in the accident. And 5 people were snatched away in such a brutal manner, and so quickly.
Salvage operations revealed the grim details. A deadly roll of the dice. Several hours before the seniors were killed, the same bus was filled with school children, traveling along the same stretch of highway. Now, the twisted wreckage is a powerful testament to how unpredictable and deadly nature can be in the snow-laden mountains of the world. As shocking as the Lyngen disaster was, such tragedies are hard to prevent, given the fragile areas people have come to settle here.
The big difference between the people that are in the mountains in recreation and the people that live in the mountains is that the people that live in the mountains that has to go to work every day or to school can't really choose if they want to go into avalanche terrain or not. So that is a responsibility that the society will have to accept and try to do the best to minimize the risk for these people.
Christensen works for the Norwegian Geotechnical Institute based in Oslo, a group that coordinates avalanche forecasting and response efforts for thousands of people living in the most vulnerable areas. As with other avalanche experts, Christensen must deal with the reality that absolute prediction is next to impossible. But with so many lives at stake, he'll use every resource at hand to try.
You can never say exactly when and how or if an avalanche is going to come down. So you cannot be completely accurate in saying this avalanche in this specific path will come 4 o'clock today. It's just not possible with the methods we have today.
A useful tool that does help improve the odds of forecasting is a computer system called Neighbor to Neighbor. It compares the snow conditions and avalanche frequency from year to year.
We compare the conditions today with what we have in our database. And then we can look at, say, 10 similar days, like the one we have today. Did we have avalanches on all of these days? Then it's probable that we will also have an avalanche today.
If conditions add up to trouble, the most pressing decision is to determine if the threat is real enough to evacuate towns or close sections of highways. Given what happened at Lincoln, this is serious business. And today, Christensen and the road authority choose to make a preemptive strike above a mountain switchback. Having placed dynamite along the summit, they will launch a slide while keeping motorists at a safe distance.
Du ser det på sträcket där.
With hundreds of roads under threat in Norway, authorities acknowledge that it's next to impossible to keep them all safe at all times.
There are so many threatened roads in Norway that to be able to protect all the roads would cost a prohibitive amount of money. It has been calculated to several billions of Norwegian kroner to protect the road to an acceptable level. So this is, I think, something we have to live with for a fairly long time, at least on the smaller roads.
The enormity of the avalanche problem hasn't stopped the Norwegians from finding new and different ways to cope. The National Geotechnical Institute has launched an all-out campaign in an attempt to gain the upper hand. Field representatives across the country are identifying the most dangerous places. Teams of photographers are taking to the air in a laborious effort to create a digital mosaic of the entire country. That new database is taking shape at company headquarters back in Oslo. New digital maps will in effect pinpoint the enemy and become valuable tools at the local level to improve avalanche forecasting, planning, and response systems. Another huge national effort underway is to train more people in avalanche rescue. Outside of Stryn, Krister Christensen is coordinating one such drill. Here, community volunteers utilize all the rescue resources available, old and new. The most critical factor in saving lives is speed.
It's very important to train these kind of exercises. The success of the search and rescue is very dependent on the time factor. The faster you start searching and the faster you find people, the bigger chance you have to rescue somebody.
The sad truth is that 50% of avalanche victims will die within 30 minutes. The number jumps to 67% in 35 minutes. Entrapped, frozen, they're immobilized, totally dependent on the quick response of others. Throughout much of the world, avalanche victims are usually unsuspecting skiers, snowboarders, or snowmobilers. But in Norway, it's a fact of everyday life. As they continue to cope, others around the world are finding new ways to live with avalanches. In avalanche country, even experts can't be totally sure of the danger that lurks around them, especially away from the beaten path. In the winter of 2000, 17 people, including 11 Austrian ski instructors and trainees, were killed in one massive slide. A half a world away, 2 Colorado men thought they too were well prepared when they set out for a half day of backcountry skiing. But out of their experience would come new hope for future avalanche victims.
Edge, I'm gonna go ahead and turn my beacon on now.
Roger that.
I got 88% battery power.
Well, we had everything. We had probes, shovels. We were both wearing avalanche beacons. We had both taken several avalanche courses. We knew what we were doing, but sometimes that can be totally outweighed by human factors. And I think that's what happened to us. We rushed into making decisions. We didn't stop and really think really hard about our route, and we made a mistake doing that.
John McGowan waited above while Bruce Edgerly cut the first few turns. To McGowan's horror, he could see what Bruce could not, until it was too late. A large slide swept Edgerly up, hurling him like a rag doll down the mountain.
Well, I never really knew it hit me until I was pushed forward and out of my skis, going head over heels. And it wasn't until 5 or 10 seconds into it that I realized that I was getting out of control and I couldn't stop, and that's when I got really scared.
Relying on his past survival training, Bruce knew that his best chance to be rescued was to fight to stay near the surface.
It started to slow down, I could feel it, but I knew that if I wasn't at the surface, then there was a good chance I was going to suffocate. So I just made one last-ditch effort just to make a lunge for the surface. And at the same time, I made an airspace with my hand.
In one desperate move, Edgerly was able to poke one of his hands through the snow, but the rest of his body was frozen in place. As McGowan frantically scanned the horizon, desperate to find his friend, Edgerly struggled to breathe, knowing time would soon run out.
My throat was completely plugged full of snow, and I could not breathe, except as the snow started to melt in my throat. It would like trickle down into my windpipe, and I'd cough, and then I'd kind of get a little bit of air, and I still thought that I might suffocate.
Through a combination of quick action and luck, McGowan spotted Edgerly's hand.
You all right? I'm gonna take you out.
Bruce would be one of the lucky few to walk away, yet the experience would change him forever.
I felt like the luckiest person on earth, really. I felt like I had been resurrected. I just gone from complete terror to ecstasy all in about 10 minutes.
His brush with death convinced him to find new ways to help others trapped in the death grip of an avalanche. And today he is teamed up with John McGowan's brother in a business that caters to winter adventurers. Their revolutionary tool is a high-tech digital avalanche beacon, the first of its kind in the world. They believe this new digital transceiver will radically reduce the time it takes to locate a slide victim, ultimately saving more lives.
In an avalanche rescue, every minute counts. And if you can shave off 5 minutes, then your chances are much, much higher surviving. It's a very sharp curve.
Using traditional analog beacons can be a slow and tedious process. They rely on an audible beep that generally gets louder the closer you get to a victim. A grid pattern of search is the only way to ensure no area is missed, but it's largely a guessing game on where to start. Time becomes the enemy.
Sign out in this direction, and then 3D, of course.
But the new digital beacon promises to cut that time in half by converting the transmission into a three-dimensional signal, displaying the direction and distance to the victim through a series of lights.
Okay, now we're doing a basic search scenario.
What's exciting about the new digital technology, it takes the interpretation process away from the user, and it's then done by the transceiver itself. You just follow the lights. They tell you what direction to go, then there's a distance indicator that tells you how far. So it's fairly easy for somebody to take it out of the box and use it.
4.0 meters out. It's going to make it within the realm of possibility for recreationalists to be rescued by their own companions rather than relying on outside parties to come in and search for them. You have half an hour maximum in an avalanche situation to get that person to the surface. And that just doesn't happen with a search and rescue.
In the world of avalanche research, the Swiss have been at it longer than anyone else. Within the majestic Alps, modern avalanche science was born. Here, new elaborate forecasting systems hold great promise for solving many of the mysteries of raging snow. The epicenter of that effort is in the city of Davos, a popular international ski destination. It's a place that typifies many other communities throughout Europe where people live and work directly in harm's way. At the Swiss Institute for Snow and Avalanche Research, revolutionary computer modeling promises to make life safer for mountain populations. Perry Bartelt heads that exciting effort, rocking the scientific world. It's the culmination of work that began here over 60 years ago.
Research in snow and avalanches began around 1938. At that time, Switzerland, or the Swiss, were very much concerned about what was happening in Europe. Hitler was in power. They were afraid of what might happen, that they might have to fight. They knew that they were going to have to fight in the mountains.
During the First World War, more soldiers were killed on the Austrian-Italian border by avalanches than actual shell fire. Fearing the onset of World War II, the Swiss began to develop avalanche research to safely move troops through the mountains. Although they ultimately remained neutral, their snow science efforts continued. Today, throughout Switzerland, snow fence barriers are a visible testament to the historic efforts to live under the constant threat of avalanches. Tom Rusi heads the Division of Avalanche Warning and Risk Management at the Swiss Institute.
In order to assess how important avalanche forecasting and avalanche research in Switzerland is, you have to know a few facts and figures about Switzerland. About 65% of the area of Switzerland is alpine terrain. There are 1.7 million people living in this area. There are about 2,000 transport facilities such as cable cars, ski lifts and tourist facilities in this avalanche-prone area. If we know better when and where avalanches might occur, we can tell people where it's safe for a particular area.
At the Swiss Institute for Snow and Avalanche Research, Russi oversees field operations, an integral part of their computer modeling effort. At a remote mountain station, Russi begins gathering clues on snowpack stability. By digging a simple snow pit, he can visually examine and compare crystal formation, identifying the weak and strong layers.
In order to do computer-aided avalanche forecasting, you need a huge amount of data right from the avalanche release zones.
It's the minute detail that the Swiss have been able to pull together in unprecedented ways. A major investment in technologies has created an elaborate network of some 80 data collection stations, reaching across the entire country. It allows the Swiss to do what has eluded so many others, simultaneously monitoring snow conditions over vast areas of terrain.
For example, we can continuously monitor wind speed, wind direction, air temperature, humidity, radiation, the snow surface temperature, which is very critical. In the past, we didn't have this data. So with the new sensor technology, we can actually measure most parameters which are relevant to assess the avalanche risk.
Every hour of the day, snowpack information is relayed from across the Alps back to Swiss Institute headquarters in Davos, giving scientists here a decided edge in better predicting avalanche risk. These new virtual tools can better calculate the odds for an avalanche strike. By measuring snowpack volumes, scenarios for potential run-out distances can be visualized. With this critical information in hand, avalanche forecasters can get the word out to local emergency officials about the level of risk in their communities. Appropriate action can then be taken.
So we have a fully integrated system, right from collecting the data in the avalanche starting zones down to computing the hazard risk on a local, regional and national level.
As populations and infrastructure continue to grow in mountainous regions, such systems are more critical than ever, as witnessed in 1999 when much of Europe was caught completely off guard. That year, across the Alps, chaos reigned, with snowslides so severe they only occur once or twice a century. Over 160 people were killed, including 31 in a massive avalanche that devastated the Austrian town of Galtur. Though it may be another 50 years before Europe experiences what the experts call an avalanche winter, the Swiss are preparing for such an event today.
After that avalanche winter, I was more convinced of the importance of numerical modeling and how that can be used to protect people. Right now, we're in the process of back calculating, verifying, calibrating our models. We think we have a little bit better information concerning the volumes that came down and also the run-out distances.
The new generation of models are anticipating slides never before imagined, helping to redefine areas that are safe to live and work. technologies which are now shared with the world in places like the United States, Canada, and Norway.
We can give these models to people who are in the local communities, people who know their particular terrain, they know the history of their region. They can make much better decisions than we can concerning how much snow is going to come down and when it's going to come down. I think this is very, very important. This is not a research effort, but it's a research effort where we deal directly with the people.
While the Swiss continue to refine the science of avalanche forecasting, the race is on in other areas to develop even newer life-saving tools. Some of the most exciting avalanche survival research is taking place outside of Salt Lake City, Utah. Here, first-time experiments are pushing snow science to new frontiers. The goal is to determine how long a human being can actually survive, fully encased in snow.
Does that depth look like it's about right from your side?
Yeah, that looks good from our end.
We got a little bit more.
All the monitors. What I'm concerned
As a deep
about is,
pit nears completion for human burial,
this printer here can print out data every minute.
a group of physicians led by Dr. Colin Grissom go over a final checklist of life monitoring equipment.
Later to a computer. This monitor right here monitors the heart rhythm via 3-lead surface ECG. It also has the attachment for the core body temperature, and one of the pulse oximeters will be hooked into this one. This monitor...
Today, team member Dr. Mary Beth Scholand will become a human guinea pig,
This one's on the right. And this one's on the right.
allowing herself to be buried alive deep in the snow for a groundbreaking test.
Start breathing?
Yeah, you might as well.
Do you have any more of these?
This is a little short here. We need
The yellow ones?
Oh, I'm a little nervous. I think I'll be cold, and I don't like that too much. And the darkness and the burial, I'm a little nervous about when my head goes under for the first time, how that's going to be.
Jump on in.
All right.
The primary focus of the experiment is to measure how fast Mary Beth's body core temperature drops in densely packed snow.
Okay, are you all the way back?
In effect, measuring the onset of hypothermia. It's an ongoing series of experiments that have never been done before.
At 12:47, we're going to start collecting baseline data. Oh, the core body temperature is 37.9. Nobody has ever prospectively studied this. Despite the large world literature on immersion hypothermia, there's virtually nothing in the literature about development of hypothermia during snow burial. So that's really the cutting edge.
Okay, I can take the Avalon now.
In the past, measuring hypothermia in snow burial victims was impossible.
Okay, arms through
They would likely die from suffocation before it even set in.
There you go.
But Mary Beth is outfitted with a revolutionary breathing device, a life-saving vest that designers hope someday will become standard mountain equipment.
Tell me when she's on.
She's on the Avalon.
Yeah. Okay.
Can hear the valves, it's working.
Okay, you guys.
Okay, the other one?
Past tests have proven that snow victims wearing the vest are less likely to suffocate, and in fact may live 2 to 3 times longer than those without it. The reason is it's designed with a porous-like membrane that allows the person to draw a supply of air right out of the snow. It also directs poisonous CO2 out the back, away from the face.
Well, we know that if we divert expired CO2 away from the area where they're inspiring from, that they can maintain adequate oxygenation for longer and won't die from asphyxiation. So then the question becomes, how quickly would they become hypothermic, and what kind of an issue would that be when they were recovered?
Complete burial. Okay, hurry now, fast.
Okay.
Completely encased in a snowy tomb, Mary Beth's vital signs are closely monitored.
37.
To the team, The implications for knowing how fast an avalanche victim gets cold are huge.
That's good. She's doing okay.
Are you doing okay there, Beth?
Yep.
Particularly since new emergency breathing devices promise to shatter old notions about surviving while being buried alive.
Is she okay still? She's got 93 sap there, that's good. She's got a pretty good tolerance for it.
As she nears the 30-minute mark, her vitals are still good.
Statistically, that person would probably be dead by 30 minutes. The Avalon's already provided more time than most people would have if they were buried in snow without the Avalon.
All right, Beth, your temperature is down to 36.1. Your saturation is doing very well at night.
But Mary Beth Scholen's experience is only half over. Current literature assumes a snow burial victim's core temperature will drop about 3 degrees centigrade per hour, which would translate to severe hypothermia. Grissom and his team doubt those findings.
How are you feeling?
Okay.
You sound like you're shivering.
Yep.
Okay, hang in there. You're doing very well.
Okay.
37.3.
Mary Beth is proving their theory. Although her temperature rapidly dropped several degrees, she is far from danger.
That's 40 minutes.
Mary Beth, you're at 40 minutes. Temperature's going down fairly rapidly, 35.7 at this point, and I suspect you're fairly cold. Other numbers are doing very well. Are you hanging in there?
Yep.
What is our time there? 42 minutes?
Yep. She's warming up a little bit.
At this stage of hypothermia, the body begins to shiver, a natural mechanism to warm itself up. As an hour nears, her temperature has actually risen slightly. Though the Avalon is discharging her CO2 away from her face, those levels are on the rise.
Mary Beth, you're at 55 minutes. You're doing very well. Temperature's 36.1, your sat's in the 90s. That end tidal CO2 is it's pretty high, it's 61.
Yeah.
And I'm sure you're feeling it.
Oh, definitely.
I think she's got an air pocket connection.
At this point, Mary Beth has had enough and wants to come out.
We're going to turn on the O2 now.
But the test was a success and adds more weight to Grissom's theory about core temperature in snow.
Okay, now we got the Avalon visible. There's her face. She's exposed. She could be off it if you want her to be.
Yeah, I think we got. She dropped to about 2 degrees centigrade per hour, which is still the quickest that we've had anybody get cold during snow burial. That's still much less than the average reported 3 degrees centigrade per hour. Pictures are left on that.
Aside from the science, it's an experience Mary Beth Scholen will not soon forget.
Okay, can you break that arm free? Okay, you got this arm free?
Absolutely terrifying to be under that snow, feel that complete tightness on your body, the constriction, the darkness, just that isolation.
Shiver Central, huh?
Yeah, I'm a total chatterer, aren't I?
You glad to be among the living again?
I am indeed. It's good to see the sky.
New life-extending equipment combined with scientific proof that the onset of hypothermia is slower than once thought raise exciting possibilities.
Good, that's what happens. There you go.
Future avalanche victims could remain buried alive for hours, radically increasing the number of lives saved.
There you go. Stand up, just get your balance back.
There's many questions left to be answered that has never been studied before in the world, and these might lead to newer ideas about the care of avalanche burial victims. So it's very exciting for everybody involved in the research. Good job, Mary Beth.
Good job.
Today, across the globe, a new sense of community is emerging, where new research and technologies hold greater promise in the quest to understand the avalanche. But it is not likely that humans will ever control such an awesome force. As winters come and go, the snows are guaranteed to remain restless and potentially deadly.
If you get in a slide, you've already made a fatal judgment of error in the